Okay, so this is a little bit more with subtraction, mainly about thinking strategies in subtraction. So the first thing I want to talk about is a four-fact family. So let me do this little picture. Get myself more room here. So first of all, this is called a number bond. If anybody's had a little bit of chemistry, it looks like the bonds between atoms in chemistry. That's why I think it's called that. But the key thing with this is just how these things relate. And it's kind of a nice visual way to think about this. But the four-fact families are basically, there's four ways of writing the relationship between these three numbers, right? So the first two are additions, and that's if 3 plus 5 is 8 or 5 plus 3 is 8, right? And these are both true. That's that commutative property, that it doesn't matter the order of adding, right? But there's two subtraction one as well. And we get those two things, okay? So for any sort of set of numbers like this that add correctly, right? You can write down always the four-fact families over there. That's a good thing to know and think about. So counting down, for example, let's just say I have 7 plus 2, and I'm thinking about how to do this. Again, this is alluding toward doing some mental math, which we will talk about in general later in the course, but this is just some start to that, right? And so what this kind of is you're just thinking, all right, I have, I'm just starting with the number 7. I'm going to count down 2 to 5, right? So this sort of falls into maybe a number line type situation. There's a couple of ways that you can kind of think of this, though, meaning going back to the same interpretations we just talked about. So if I'm 1, 2, 3, 4, 5, 6, 7, there's 7, right? So if I'm thinking about the part-whole interpretation, right, I can think about there's 2, right? And there's the rest, right? So the whole thing is 7. This is 5. So this is counting down, meaning starting at 7, going 1, 2 to get to 5, right? But, excuse me, notes went away. Takeaway looks very similar. I start with 7. I take 2 things away. Right, where am I? So this is, I have 7 pieces of candy. I give 2 of them away. Where am I? Boom, boom, like that. And then comparison. Let's just bring that over here. Okay. And sometimes I'm going to use these little bars. 2, 3, 4, 5, 6, 7. Right. And this is one of these things, if if this stick is 7 inches long, this other stick is 2 inches long, how much longer is the first stick? Right. So this is a real good picture for that. Question mark. Right. So this is 7 up here. And that's 2, and it's 5. And so you can think about, again, counting down like that as well. Okay. There's also counting up. And let me do this one instead. If these are close to each other, counting up is maybe a little bit easier, meaning starting at 5 and counting to 7. And the picture with this is often a number line. Right. I start at 5, I go to 7, and I get that for 2. Okay. Now, for something like this, you might think, well, that's kind of crazy. Am I going to do counting up on that? The way I would do that is I would start at 5, right, and count up to 27. And again, students, like, this is a really common way for students to do it. I've seen it with my own kids. And they really sort of, like, once they sort of figure out some way to do it, they kind of glom onto that. So you got to kind of make sure you kind of break them out when things get a little bit crazy. So now a better way to do this may be to count from 5 up to 7, and then know you can skip by 10s for that. So a nice picture for that would be, here I'm at 5, right, and I go 6, 7, right, and then I go, there's 2, I skip 10, and I skip 10. And you can do counting down exactly the same way. So, meaning jump a couple of 10s and then down a couple of 2s. Yeah, so counting up, counting down really are just how am I thinking about it? Am I counting starting at the bigger number going to the smaller, or vice versa? Okay, and then the last one in this is compensation, which we had in addition, and you got to be really careful with this if you're using compensation with this. It's really hard to mix. It's easy to mix these up. So let's take a look at this. So what I mean by this is really this is the same as 10 minus 5. You can think about it that way, right? Because that's just 5 and that's just 5. But the picture of it is really good in terms of, let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to put 9, 1, 2, 3, 4 here, right? And so here is the difference, right? The result is that. And basically, if I just take that, you can think about a bar of that length. I could slide it any way along that. So what do I have to do? To keep that the same length, I have to add or subtract the same amount to both of those. Okay. Now, how is this helpful? So let's say I have, I'm doing something a little bit bigger. I'm going to do 37, say, minus 14. Something like that, right? Actually, let me do something a little bit. Let's do 37 minus 19. Okay, so what I'm going to do with that is, I can imagine on a number line like this, and I'm just going to be sliding those two numbers back and forth. So I can add or subtract the same to both of those without changing anything. Well, the key thing here is if I add 1 to both of those, then I have this. This, if you're trying to think about how to do that in your head, a natural thing might be is to do the column algorithm and do that. Well, you got to do some borrowing to make everything work out right, which gets a little bit complicated in your head. As soon as I've added that, right, This is simply 18, right? 3 minus 2, and 8 stay the same. So that's a really nice sort of thinking strategy. We're going to exploit this a lot when we get to really doing mental math. A lot. So. Okay, so that wraps up this video.